Now we can see what is nuclear fission. What is nuclear fission? When a heavy nucleus is bombarded by a slow neutron or a thermal neutron, the nucleus splits into two nearly equal fragments along with the emission of energy and two or three fast neutrons. So when a heavy nucleus, for example, we can consider the heavy nucleus as uranium-235. When it is bombarded with a slow neutron, thermal neutron, what happens? That is N0, N1 gives an unstable uranium-236 nucleus. Since it is unstable, what will happen? It will split itself into two nearly equal fragments, that is barium-141 and krypton-92, along with what? Emission of two or three fast neutrons plus releasing energy. This process is called as nuclear fission. Clear? This definition as well as the equation you have to study. Then nuclear fission reaction itself, that is fission reaction itself, it can be sometimes called as chain reaction. Why we call it as chain reaction? That is under some favorable condition. When certain conditions are satisfied, what happens? The neutrons emitted, that is, as I said earlier, 2 to 3 neutrons are emitted. That 2 to 3 neutrons, what they do? They cause further emission of or further fission of uranium nuclei and releasing energy. And when this further fission occurs, again neutrons are made or neutrons are released, which again cause fission. So that reaction, that is, first fission causes 3 neutrons, which causes 3 more fission. That 3 more fissions releases 3 neutrons, that is 9 neutrons altogether. That 9 neutrons again causes 9 fission. And likewise it goes on continuously till what time? Until the whole of the uranium is consumed or fissioned. That process is known as nuclear chain reaction. That is, from one fission we are continuously going on to next fission reaction. Such a fission reaction we call it as nuclear chain reaction. Now this nuclear chain reaction is of two types: controlled chain reaction and uncontrolled chain reaction. Now we can see what is controlled chain reaction. First, what is controlled chain reaction? Controlled in a controlled manner. So how we can control? In this reaction, only one of the neutron emitted in a fission causes another fission. Then the fission rate remains constant and the energy is released steadily. Such a chain reaction is called controlled reaction. That means, as I said, the fission reaction, they gives out 2 to 3 neutrons. If we are making only one neutron to fission at a time, then what happens? We can control it one at a time, then again one more neutron and next time. So like that, when we are controlling it or when we are making the situation such a way that only one neutron causes another fission, then the fission rate also remains constant, as well as energy released will be also in a constant steady pattern. Such a reaction we call it as controlled reaction. Example, nuclear reactor, which we use it for producing or generating energy. The next is uncontrolled chain reaction. From the word itself, no control. That is, if more than one neutrons emitted in a fission causes further fission. We know the fission rate will increase rapidly, and as a result, within a few seconds, within a few moments, what happened? The whole material gets what? Fissioned, with releasing a lot of energy in a short period of time with a violent explosion. Such a chain reaction is called uncontrolled chain reaction. Example, nuclear bomb. We have seen in Hiroshima, Nagasaki, the effect of nuclear bomb, right? Within a few moments, within a few seconds, continuously the chain reaction happens until the material, the fissionable material is completely exhausted. And within a few minutes, what happens? A huge amount of energy is released with a violent explosion. Such a chain reaction, nuclear chain reaction, we call it as uncontrolled chain reaction. Then next we are going to see what is a nuclear reactor, what are the parts and functions of in this nuclear reactor, what are the parts of nuclear reactor and what are its function. So first, what is a nuclear reactor? A reactor or a system, or it is a device in which self-sustaining controlled chain reaction is produced. That is, we are producing a controlled chain reaction so that we will get energy. Such a device we call it as nuclear reactor. Then next is its parts and function. First part, we know in order to nuclear reactor means we need first a fuel. That fuel means the fissionable material is known as fuel. Example, uranium 235 or plutonium 239. Then next is moderator. What is moderator? It slows down the neutron to thermal energies. Actually, in a chain reaction, the 2 to 3 neutrons which are released, which are emitted, they will be fast neutrons. And since they are very fast neutrons, they move out or they go out of the fissionable material very fast, which causes no reaction. So we slow down the neutrons which are emitted and we continue the chain reaction. So moderator is a material which helps to slow down the neutron to thermal energies. Example, heavy water, graphite, beryllium oxide. The best moderator is heavy water. The next is coolant, from the word coolant. That is, we know when energy is released inside a reactor, it will be released in the form of heat. It will release heat energy. In order to absorb that heat and make the reactor cool, what we use? We use coolant. An example is air, water, carbon dioxide. The next is control rods. Control rods, from the word control, right? So here this, in order to control the fission rate, here the control rods, the best their use is to control the fission rate in the reactor by absorbing slow neutrons. That is, if there are lot of slow neutrons, mean what will happen? The reaction rate will increase. So in order to make it control, the excess slow neutrons are absorbed by this material and they maintain the reaction rate. So they are used to control the fission rate in the reactor by absorbing slow neutron. Example, cadmium, boron. Okay. The next is shield. Shield means a protecting cover. We know the nuclear reactions, they give out highly radiating or radioactive rays outside, which causes cancer, many other diseases, right? So they are highly radioactive. So in order to protect from such radiations, what we build, you must have seen in the pictures of nuclear reactor, a thick, very thick concrete walls are built around the reactor so that the radiations won't go out. Clear? That protective covering concrete walls are called shield. The next is safety rods, from the word itself. It is for safety. The safety rods are also known as shut-off rods. Shut-off rods. Now these are the special set of control rods known as shut-off rods which enter the reactor automatically. They immediately absorb the neutrons and stop the chain reaction completely. That means they are actually a set of control rods itself. What is the function of control rod? To absorb slow neutrons, right? So here a set of control rods will be introduced into the reactor automatically. That is, it is happening during emergency or accident cases. So they enter into the reactor and they absorb all the slow neutrons. Immediately they will absorb all the slow neutrons. So when they absorb slow neutron means what happens? Fission cannot further proceed. The fission reaction will stop. So in order to control or in order to protect our severe accidents and all, we use this safety rods. During the emergency cases or accident cases, this rods will enter the reactor automatically and they will shut off, they will stop the chain reaction completely.